Hey there, science fans! Welcome back to another exciting episode where we unravel the mysteries of the tech world. Today we're diving into the fascinating and intricate world of PWM controllers. These little devices might seem complex at first, but trust me, they're incredibly useful and quite ingenious. Don't let the fancy name scare you. PWM stands for pulse width modulation. It's a technique used in various applications, from simple household electronics to sophisticated industrial machinery. It's a clever way to control things by sending pulses of electricity. Instead of delivering a constant stream of power, PWM sends out bursts of energy at precise intervals. Think of it like turning a light switch on and off really fast. By adjusting the duration and frequency of these pulses, we can control the amount of power that reaches a device. Instead of a steady flow of electricity, we get short bursts. This method is not only efficient but also allows for precise control over various electronic components. This pulsing action allows us to control the average amount of power delivered. Pretty neat, huh? For example, by varying the pulse width, we can dim a light bulb or control the speed of a motor. PWM controllers are like tiny conductors orchestrating this electrical symphony. They ensure that each component gets just the right amount of power at the right time. Let's explore further and see how these pulses work their magic. We'll delve into real-world applications and understand why PWM is a game-changer in the field of electronics. Stay tuned! Now imagine each pulse as a heartbeat. The duty cycle is like how long your heart squeezes to pump blood. In PWM, it's the percentage of time the pulse is on versus off. A high-duty cycle means longer on periods, delivering more power. Picture a bright light. A low-duty cycle means shorter on periods, like dimming the light. This simple concept of varying the on time gives us amazing control over all sorts of devices. It's like having a volume knob for electricity. Remember those pulsing heartbeats? Frequency determines how fast or slow they beat. In PWM, it's how many pulses are sent per second. A high frequency means lots of quick pulses, like a hummingbird's wings. A low frequency means fewer, slower pulses, like a relaxed heartbeat. The frequency we choose depends on what we're controlling. Some things need fast pulses, while others work better with slower ones. It's all about finding the perfect rhythm for the job. So how does a PWM controller actually work? Let's dive into the fascinating world of pulse width modulation, or PWM for short. This technology is at the heart of many modern electronic devices, making them more efficient and versatile. Think of it as a tiny computer chip with a special job. This chip is designed to control the amount of power delivered to various electronic components. It's like having a mini brain that makes real-time decisions based on the instructions it receives. It receives instructions like how bright you want an LED. Imagine you're adjusting the brightness of a lamp in your room. The PWM controller takes your input and translates it into a specific signal that tells the LED exactly how much light to emit, or how fast to spin a motor. Whether it's a fan, a blender, or even an electric car, the PWM controller ensures that the motor runs at the desired speed. It does this by rapidly switching the power on and off, creating a smooth and efficient operation. Then, it creates the right PWM signal with the correct duty cycle and frequency. The duty cycle determines how long the signal stays on versus off, while the frequency dictates how often this cycle repeats. Together, these parameters control the power delivered to the device. This signal acts as a set of instructions for the device, telling it exactly how much power to use. It's like giving precise directions to a driver, ensuring they follow the best route to reach their destination efficiently. It's like a conductor leading an orchestra, ensuring every instrument plays at the right volume and tempo. Just as a conductor brings harmony to a musical performance, the PWM controller brings balance and precision to electronic devices. The PWM controller is the maestro of the electrical world. It orchestrates the performance of various components, making sure everything works together seamlessly. From lighting systems to motor controls, this tiny chip plays a crucial role in our everyday technology. Section 5. PWM in action. From motors to mood lighting. PWM controllers are like versatile helpers found everywhere. They're used in motors, controlling speed in fans, power tools, and even electric cars. They're also used in LEDs, adjusting brightness in everything from your phone screen to traffic lights, and in power supplies, regulating voltage for computers and other sensitive electronics. And that's just the tip of the iceberg. PWM is a fundamental technology used in countless applications, making our lives easier and more efficient. Section 6. Imagine this, PWM in everyday life. Let's say you're baking a cake. You gather all your ingredients, mix them together, and pour the batter into a pan. But the real magic happens when you put it in the oven. You wouldn't crank the oven to the highest setting and hope for the best, right? That would likely burn the cake or leave it undercooked in the middle. Instead, you'd adjust the temperature to the perfect setting, ensuring that your cake bakes evenly and comes out just right. This careful control is crucial for achieving the best results. PWM, or pulse width modulation, is like that oven knob, allowing precise control over electrical devices. It's a technique used to adjust the amount of power delivered to a device without wasting energy. It's the reason you can dim your lights to create the perfect ambiance in your living room, adjust your laptop's screen brightness to reduce eye strain in a dimly lit room, and even control the speed of your blender to get the perfect consistency for your smoothie or soup. Without PWM, our world would be a much more on or off place, with devices either running at full power or not at all. This lack of control would make it difficult to achieve the precision we often take for granted. With PWM, we have the ability to fine-tune our devices, giving us greater control and efficiency in our everyday lives. From the kitchen to the office, PWM technology helps us achieve the perfect balance in our electronic devices. Section 7. Why PWM rocks efficiency and control. PWM isn't just about fancy features, it's also incredibly efficient. By delivering power in pulses, it reduces wasted energy and heat. Remember that dimmer switch? PWM allows LEDs to shine at different brightness levels without wasting energy as heat. This means longer battery life for your devices and a happier planet. PWM's precise control also extends the lifespan of devices by reducing wear and tear. It's a win-win situation. Section 8. PWM, the unsung hero of modern electronics. PWM controllers might work behind the scenes, but they play a crucial role in our increasingly electronic world. From smartphones and laptops to electric cars and renewable energy systems, PWM is everywhere. Next time you dim the lights, adjust your fan speed, or even use your electric toothbrush, remember the magic of PWM at work. It's a testament to human ingenuity, finding elegant solutions to control the flow of electricity and shape our modern world. Section 9. Keep exploring. So there you have it, PWM demystified. We've gone from basic definitions to real-world applications, all while keeping it light and engaging. But the learning doesn't stop here. There's so much more to explore in the world of electronics and beyond. So keep that curiosity alive, and never stop questioning, experimenting, and discovering the wonders of science.